right, so here we have an exponential function, right? You know it's an exponential function because the exponent is the variable, is the x, right? As opposed to this, that has an exponent, but the exponent is 2. That's a quadratic function. We have an exponent of x, we call that an exponential function. And these are written in this form. Okay? So I think the best way to do this, if we have to graph this, is maybe write down a equals 3, b equals 2, right? Okay. The a stands for the initial value, and the 2 stands for the multiplier. All right? Now, before we graph this, I think it's a good idea to look at the function and determine if this is an example of exponential growth or exponential decay. Whatever's happening here are the numbers getting bigger or smaller? What do you think? Growth or decay? Yeah, good. This example of exponential growth. So the rule is this. If the b, right, is greater than 1, that's the multiplier, that's growth. Because the b is what you multiply by. If you multiply by something greater than 1, then the thing you're multiplying gets bigger, right? It starts growing. If you multiply by 1, it stays the same. Multiply by something bigger than 1, it starts getting bigger. All right? So in this case, the b is 2. That's bigger than 1. That's growth. Decay is this. If the b is bigger than 0, greater than 0, but less than 1, that's decay. These questions, you will not see one in here where the b is negative. Okay? So there's only 2 options for the b. The b is either between 0 and 1 or greater than 1. Okay? So if you wanted to see that on a little chart, it would look like this. If b is in here, that is decay. If b is over here, that is growth. What if the b were 1? What would that mean? It'd stay the same. You'd be multiplying by 1, right? Okay, so b is not going to be 1, b is not going to be negative. It'll be something between 0 and 1, that's decay, or something greater than 1, that is growth, right? Our last question that we did with the height, which one was that, decay or growth? It was decay because the last one we did, the multiplier was 0.997, right? That's less than 1, right? Okay, so this is an example of exponential growth because our b is bigger than 1, right? Now let's graph this. This is really important. All right. So I'd say the best way to graph this is to just start making an input-output table here. And we'll say, well, all right, if x is 0, what is y? If you put 0 in for x on that blue function, what would you get? Get 3. It'd be 3 times 2 to the power of 0. This is 1. 3 times 1 is 3, right? It's the initial value. Okay, what if you put in a 1? Yeah, good, you get it out of 6, right? 2 to the first times 3. 2 would be 12. 2 to the square is 4 times 3 is 12. 3 would be 24. 3 here would make an 8, right? 2 to the third is 8. 3 times 8 is 24. 4 would be 3 times, this would be a 16, right? 3 times 16 is 48, right? I'm just going to start putting these on. Let's see what this looks like. 0 and 3, put that here. 1 and 6, 2 and 12. Can you see what's happening to the line? The space here is getting bigger each time. It's getting steeper. So what this looks like is a curve that goes up like that. The higher the b is, the steeper that thing's going to go. The faster it's going to start going up. Okay? So we did this side. What about over here? What if we put in a negative 1? What's that going to give us? That would be this. 3 times 2 to the negative 1 power, which is 3 times 1 over 2 to the first, or 3 times a half, which is 3 over 2, right? Or 1.5. How about negative 2? That would be 3 times 2 to the negative 2, or 3 times 1 over 2 squared, which is 3/4. Right? This is the same as this. Right? Negative exponent. 3 times 1. 1 times 4. Okay? Alright, so we got, let's see, negative 2. What about negative 3? We got a negative 3 here. It's going to be 3 times 1 over 8, or 3/8. Right? Look, these numbers here are getting smaller and smaller, right? As we go this way, they get lower and lower, right? But it's important to realize they're never going to get below this. Oops. They will never drop below the x-axis on this. It's the asymptote. No matter what you put in there. Put something like a negative 100. If I put negative 100 up here, is that going to make my line, my curve, drop below the axis? Is it going to give me a negative y value? Is this going to make a negative number? No. Negative exponents don't make negative numbers. Right? This is going to be this. It's going to be a really, really small number, but it's not going to be negative, is it? Okay? So this is an example of exponential growth. Alright? This is what the growth looks like. This would be an example of, or can anybody think of like an example that you could use, a story you could tell that would fit this? A mouse population? Yeah. So what's the story? You start out with 3 mice, right? And every month you go back, the mice population doubles, right? So at first you have 3 mice. Then you go back a month later, 1 month later you have 6. 1 month later you have 12. 1 month later you have 24, okay? The mice population's doubling. That's what this could be. All right? Any questions? No? Okay, let's try example 2. So what we did, we just graphed an exponential function, right? Made a little table. Exponential growth looks like this. Starts to shoot up. Okay, number 2. try to graph this. Growth or decay? Decay, good. This is decay because the b is less than 1, right? Does that make sense? It's greater than 0, but it's less than 1. It's a half. Every time you multiply by a half, stuff gets half as big, right? So let's see what this would look like on a little table. 0, when x is 0, y is... If x was 0, this whole thing would be 1, right? Anything to the power of 0 is 1. So 4 times 1 is 4. Right? After x is 1, you get 4 times a half is 2, right? Here's an example of what this is. This is like this. You live in this imaginary world where apples are really valuable, and you have 4 of them. And you're sitting in your hut or your little house, and you got 4 apples on the table, and you're really happy about this because apples are really valuable. But then the king comes by and he says, every day I'm going to come to your house, I'm going to take half of your apples as a tax. How many ever apples you have to give me half of them every day as a tax. So you're kind of mad, but whatever. You die if you fight the king. So no days have gone by, you have all 4 apples. Day 1 comes along, the king knocks on your door, and he comes in, and he sees these 4 apples, and he says, oh, 4 apples, huh? Well, I take half, so give me half your apples. And he takes 2, and you're left with 2. Right? All right. You go to bed. Next morning you wake up. It's day 2. The king comes knocking on your door, and he says, I see you have 2 apples there. You have to give me half of your apples, you know. But you're like, but I only have 2. He says, it doesn't matter how many you have, how rich you are, or how poor you are. Everybody gives me half of what they have. So give me 1 of those apples. You have 2, give me half of them. Okay. Now you're left with 1 apple.
How do you multiply that?
Right? Okay, that's a good question. That's like this. It's this rule. Right? Okay, so 2 times 1 is 2. 2 times 1 up here is 2. So what you have is 4 times 1 over 4. 4 times a fourth is 1, right? Okay. So day 3 comes along. You wake up early. You hear this loud knock on the door. King opens it without you even letting him in. And he says, give me half your apples. And you say, but king, I only have 1 apple. He says, I don't care. You need to cut that apple in half. Give me half of it. Alright. So, now you have how many apples? Half an apple. See, that would be this. 4 times a half, day 3 to the 3rd. That's 4 times 1 over 2 to the 3rd. Or 4 times 1 over 8. 4 times an eighth is 4 over 8, which is a half. Okay? Now, the bad news is that you started out with 4 apples and now you only have a half an apple left. The good news is you're losing less apples per day. I mean, the first day you had to give up 2 whole apples, right? But just yesterday you only had to give up a half an apple. So because you have less, you give up less, right? That's why this is the exponential curve. Okay, day 4. Oh no! King knocks on your door and there you are sitting with half of an apple. And you're wondering, when am I going to pass down to my children? The king says, give me half of what you have. And you say, I only have half an apple. What do you want me to do? He says he wants you to cut that apple in half. Right. And give me half of it. And you're like, oh, now I only have a quarter of an apple. See? 4 times a half to the 4th. 2 to the 4th is 16. 4/16 is a quarter. We have a quarter of an apple. And you're thinking, this couldn't possibly get any worse. Started out with 4 apples, was the richest person in this town, and now I only have a quarter of an apple left. Day 5 comes, and the king says, cut that quarter of apple in half and give me half of it. Now how much would you have? An eighth, right? So he does that. And you say, let's go about a half there. That's probably too much. You measure it out perfectly because these apples are so valuable. You don't want to give up more than you have to. And you only have an eighth of an apple left, and you start to sort of get sort of rude, which people usually don't get with the king because he's cut people's heads off before for saying things like this. But you tell him, the king, just like 5 days ago, I had 4 apples. Now I only have an eighth of an apple left because of you. I even created this little graph here to show you what's happening. Look at this graph I made. Look, see this? Day 4, or day 0, I have 4 apples. After 1 day, I only had 2 apples. After 2 days, I only had 1 apple. See what's happening, king? After 3 days, I had a half an apple. And so on. Look, if you keep doing this to me, I'm not going to have any apples left. I'm going to run out of apples. I'm going to be left with nothing. So mean. You're terrible. Tyrant. You can take away all my apples. And the king says, let me take a look at that graph. He looks at it and he shakes his head. He says, no, I'm not as mean as you think. I would never leave you with no apples. That's not what this graph looks like. You made a mistake. What's the problem with this graph? You'll never have 0 apples, right? You just take a half away each time and you'll still be left with something. This graph actually looks like this. So, I'm not that bad of a person. Just because I take away half your apples doesn't mean I'm going to leave you with nothing. You'll always have something. You'll always have a little tiny bit down here. Okay? This is an example of exponential decay. Alright? Any questions yet? Sure? Okay, now, the reason why I wanted to do this, we're going to do 2 more of these, is because I want to compare real fast. 1 and 2. 1, where is it? This one. This is the mice one, right? That's growth, right? The b was bigger than 1. And I want you to look at the shape of the graph. See how it starts out over to the left, like real low, and then it gets steeper and grows up? And And now look at 2, the decay. The shape is totally different. Growth looks like this. Decay looks like this. Okay? So what we have here is an example where you could say, all right, well, this is an example of exponential decay, right? That happens when the b is less than 1. That's like question 2. That's the king with the apples, right? The amount of apples you have is getting lower. Exponential growth looks like this. That's like number 1. That's the mice. Your graph will look like this if the b is greater than 1. Okay? So you should just kind of keep that in mind. Then when you have to graph one of these, if it's growth or if it's decay, you already have a picture in your mind of about what it should look like. Okay? Any questions yet? No? Okay, now we're going to do 2 more of these graphs, right? And what I'm doing basically is just the functions are y equals a times b to the x, right? And we just talked about, well, if b is less than 1, you'll get the blue. If b is greater than 1, you'll get the red. And b is not going to be negative, right? Now let's mess around with the a and see what that does to the graph. Because both of these questions, the a was positive number, right? Like the blue one, the a was 4. The red one, the a was 3, right? So this is a b less than 1, positive a. This is b greater than 1, positive a. Okay? So let's try, I don't know, b greater than 1, negative a. Let's see what that looks like. Okay? And then we'll try the last one, b less than 1, negative a. That'll be all 4 shapes that we need to do. Okay? All right, number 3. Y equals negative 2 times 3 to the x power. So here we have an exponential function. It looks like growth, right? Because b is bigger than 1, right?
So input output table, the best way to do it.
Yeah, we'll do this again. And we'll be able to tell what this looks like. It's growth. You know, the last time we did growth, it did this. We'll see if the a is negative, is it going to change, or is it going to just be the same? So, if x is 0, what would y be? It would be 2, negative 2, yep. X is 1, y is negative 6. X is 2. Uh-huh. Right? It'd be 2 times 3 to the third. Okay, let's graph this much of it and see what this looks like. 0, negative 2. 1, negative 6. 2, negative 18. Now it's dropping fast. Right? Looks like it's doing this, right? So it doesn't look the same as the other growth curve, does it? No, it doesn't look like this. Okay. What about, let's try some points over here, negative x's. X is negative 1. What's that going to look like? Negative 2 times 3 to the power of negative 1, which would be negative 2 times 1/3, which is negative 2/3, right? And here. How about negative 2? That'd be negative 2 times 1 over 3 squared, or 1 over 9. Negative 2/9. Even smaller than negative 2/3, or at least closer to 0. Now the question is, as this gets like this and it gets closer to 0, is it ever going to touch 0? Or is it ever going to cross the axis and be up here? Are we ever going to have a positive y value? Are these numbers over here ever going to become positive? No. Even if you went way over here to negative 100, you're still going to get a negative number out. You'll have negative 2 times 3 to the negative 100th. Negative 2 times 1 over 3 to the 100th power. Which is a negative times a positive, still a negative. So, here we go. Okay? Alright, that's exponential growth with a negative a. So, let's add that to this. I'll do it with green. That looks like this. Right? And next to this one I'm going to write number 3. This is a growth. The b is bigger than 1, but the a is negative. Okay, so we're just getting like 4 different options here. What do you think the last one's going to look like? Can you tell? Yeah, I think it's going to be like this. Right? Okay. These aren't exact, correct graphs, but this is general shape. So what we have is the options for b are b is either less than 1, greater than 0, or b is greater than 1. That's the 2 options for b. The 2 options for a are a is either positive or negative. Okay? So if you have 2 options for each, you mix those up, there's a total of 4 combinations. So the last one we have to do is b is less than 1 and a is negative. Right? Number 4. So a is negative, b is less than 1. This looks like decay, right? Two looks like this. Another way to do, you guys have a hard time with the exponents. What you could do is, the multiplier is 1/3, right? So you just take this and you multiply it by 1/3. That's what's happening. That's why this is a exponential function. You take every time you multiply by 1/3. That's what you're doing, right? So if you don't want to go back and plug this in here, right? So, oops. What would be 4? Negative 1/9 times 1/3 is negative 27. 0 and negative 3. 1 and negative 1. 2 and the third negative. Closer and closer. It's going to look like this, right? Never touch the x-axis. We can go the other direction. Negative 1. What's that? Anybody know what that would be? What's x is negative 1, y would be negative 9, yeah. Negative 3 times 1/3 to the negative 1, that's this. Which is this. Which is negative 9. Negative 2 would be negative 27. So we're moving backwards now. So instead of dividing or multiplying by a third, we're dividing by a third, which is multiplying by 3. Alright, so as you could tell, as we move to the left here, the numbers start dropping off real fast. Negative 1 would be down at negative 9. And then way down at negative 27 on the next one, that looks like this. Okay, so that's the last one. Tomorrow we'll talk about how you can shift these graphs around. There'll be like an h and a k in the equation. But for now, just get this good. All right? So there's basically 4 types of exponential functions you're going to have to be able to do on the test. And they are these right here. I need another color. How about orange? The last one looked like that, right? That was question 4. That was decay. B was less than 1, but the difference between orange and blue is that we had a negative a. Okay? Any questions yet? So I'm going to give you guys some homework. You can practice this. Are you ready? Yeah? Okay, just a real quick review here, I guess. Exponential functions. B is greater than 1, that's growth. Less than 1, greater than 0, that's decay. That's a growth function. That was the mice. This is a decay function. That was the apples. Here's a growth with a negative a. Here's a decay with a negative a. Okay? Okay.